you get me that rebound number?
Yep, no problem.
What just happened?
Crap. Wrong hammer.
On a lot of job sites, the rebound hammer gets called Thor's hammer. And honestly, it earns the nickname. It's satisfying, it goes crack, and it makes you feel powerful. But here's the thing about Thor's hammer. Not everyone who picks it up is worthy of it. This tool looks like it tells you concrete strength, and it does not. Misreading that one number is genuinely one of the most common mistakes in the whole field, made by rookies and by engineers who should know better. So today we're going to make you worthy. What this thing actually measures, when to trust it, when to put it down, and how to swing it right. This is a training overview. Always follow the current ASTM C805, your project specs, and site safety requirements. Let's expose the imposter first. You press the hammer to the concrete, pull the trigger, it goes crack, and a number pops up that looks exactly like a strength reading. So people write it down as strength, on inspection reports, on is this slab okay? Decisions, sometimes on whether concrete gets torn out. And that is the trap, because the hammer never measured strength. Not once. It measured how hard the surface is. The number is real, the meaning people give it is usually fiction. Whosoever misreads that number is, as they say, not worthy. So what does it actually measure? Inside the hammer is a spring and a mass. You pull the trigger, the spring fires the mass into a plunger that's pressed against the concrete, and the mass bounces back. A harder surface throws it back farther. A softer surface soaks up more energy and throws it back less. That bounce gets turned into a rebound number. And that's the whole magic. It's really a near-surface response, driven mostly by surface hardness and stiffness. Now, that response and compressive strength are related, sure. They're cousins. But they are not the same person, and the space between them is this entire lesson. So here's the line to remember. The rebound number is not strength. It's a screening tool wearing a lab coat. And I'm not just being cute. ASTM C805 itself is clear that an uncorrelated rebound number isn't a basis for accepting or rejecting concrete. The people who wrote the method built that limit right in. So when someone waves a rebound number around like a verdict, they're arguing with the standard itself. Respect the tool for what it is, and it'll serve you well. Now, don't get me wrong. When you use it for what it's actually good at, this hammer is fantastic. It's a comparison tool. Want to know if a slab is uniform or if one corner cured soft? Sweep it, and the relative numbers tell you fast and cheap. Trying to find the odd spots in a big structure, the areas that read unusually high or low, the hammer flags them for a closer look. About to spend real money coring? Use the hammer to decide where to pull those cores instead of coring blind. Relative comparisons, this spot versus that spot, are its genuine superpower. Lean on that, and it's one of the best, cheap tools you own. Here's where it is absolutely not worthy. 1. As a standalone strength number. The hammer said 4200 psi is not a strength result, full stop. 2. As acceptance or rejection. You don't pass or fail concrete on an uncorrelated rebound number alone. That's not a call the hammer gets to make. And 3. Without a job-specific correlation. If you don't have a correlation curve built for this exact concrete, you don't have a strength, you have a bounce. Use it in any of these 3 ways, and you're not doing a test, you're doing a magic trick. So can you ever get a strength estimate out of it? Yes, but only the right way. You take your rebound readings at selected spots, then pull cores from those same areas. Break them per ASTM C42 and plot rebound number against actual core strength. That relationship is yours for that concrete, that hammer, that surface, moisture, and orientation. And notice it's cores from the structure, not molded cylinders. Cylinders cure and sit differently than the concrete in place. What doesn't work is borrowing somebody else's chart, or the generic curve printed on the hammer, because those were built on different concrete. The correlation is the thing that turns a bounce into a number that means something. Now, the mistake your gut probably already knows: grabbing the wrong hammer. They are not all the same, and the difference is impact energy. The Type N is the standard, about 2.2 Newton meters, for normal weight structural concrete at least 4 inches thick. That's your everyday hammer. The Type L has about a third of that energy, a lower impact tool for small, thin, or impact-sensitive elements within the manufacturer's limits. There's also a specialized high-energy hammer for mass concrete and pavements, but check the manufacturer and project before you reach for it. Grab the wrong energy for the member, and the number is fiction. Now you'll also hear about digital hammers like the Silver Schmidt. They'll compute and even orientation correct for you. And they're great, but heads up, they still come in those same N and L energies. Digital isn't a magic third type. Confirm the model and the energy, and this is the big one. You can never compare readings across different hammer types. Each one needs its own correlation. Wrong hammer, wrong answer, every time. Okay, you know what it is and what it isn't. Now let's make you worthy of actually swinging it. There are 6 steps between you and a rebound number that means something. And just like the last few episodes, every step has a place it can quietly betray you. Let's go. Step 1. Prove the hammer before you trust it. Inside is a spring and a mass, and springs get tired, and mechanisms get gummed up with dust. So you verify it on the specified steel anvil. The ASTM anvil is built so a properly working hammer reads at least 75, and your hammer's maker gives you the exact expected value. Around 80 is typical, but match your hammer spec, not a rule of thumb. And notice I said verify, not calibrate. The anvil check confirms the hammer's working. It doesn't set a strength relationship. Do it at least once a year, and anytime readings look strange. Here's the tell. An unverified hammer lies to you with total confidence. Same clean number, quietly wrong. Prove Mjolnir on the anvil before you swing it. Step 2. Prep the surface, or the surface will lie to you. This hammer only feels the top few millimeters of concrete, so the surface has to represent what's underneath. Test a clean, smooth spot and grind rough or textured areas only as much as you need, prepping every comparison area the same way. Never compare a ground surface to an unground one. For a standard Type N hammer, the member should generally be at least 4 inches thick, or a thinner piece rigidly backed, because a loose thin panel just soaks up the blow and reads low. And moisture matters. A saturated surface reads differently than a dry one, so keep the moisture condition consistent across your comparison areas and write it down. Don't compare wet to dry. The tell. Smooth it, back it, note the moisture, then swing. Step 3. Know where not to strike. Stay off spots directly over reinforcement, especially where the cover's shallow. Around 3/4 of an inch or less is where the steel really skews you. Locate the bars before you lay out the area. Keep every impact at least 2 inches back from edges and corners, and avoid honeycomb, scaling, and near-surface voids. Hard aggregate right under the tip can spike a single reading too. And watch old, carbonated surfaces. Over the years, the skin hardens chemically, so an old carbonated face can read higher than the concrete underneath really is. The tell. Carbonation is the sneakiest one. Don't compare a carbonated surface to fresh concrete, and if it really matters, core it. Step 4. 10 readings, not one hero swing. You lay out a test area and take 10 readings, no 2 closer than an inch, and every one at least 2 inches from an edge. Hold the hammer perpendicular, straight on, not cocked, and press firm and steady. Here's a step people skip. After each hit, glance at the mark. If the tip crushed into a void, throw that reading out and take another at a good spot. Record each one to the nearest whole rebound number. That grid marked on the concrete isn't decoration. It's the entire method. 10 spread out reads average out the aggregate and voids you can't see. 1 whack is a rumor. 10 is data. Step 5. Throw out the liars, then average the rest. Take your 10 readings and find the average. Any single reading that sits more than 6 units away from that average, discard it, because you probably clipped a rock or dropped into a void. Here's the important part. If more than 2 of your 10 are outliers, the whole set is no good. You throw it all out and retest at 10 fresh locations. Then you report the average of what's left. The tell. Scattered readings aren't noise to ignore. They're the concrete telling you this spot isn't uniform or your technique slipped. The discard rule is your built-in honesty check. Step 6. Direction changes the number, so log it. Swing the hammer horizontally into a wall, straight down onto a slab, or straight up into the underside of a beam, and you'll get 3 different rebound numbers off the exact same concrete, because gravity is either helping or fighting that little mass inside. So you keep your direction consistent, or you apply the orientation correction that's specified for your particular instrument. And you always record the orientation with your result. The tell. 2 techs on the same wall, one shooting up and one shooting down, walk away with different numbers, and both blame the mix. Log the direction, or your data can't be compared to anybody's, including your own from last week. Let me bring back an old friend, the honest liar. Just like the air meter, the rebound hammer always gives you a number. It just never tells you whether that number is true. Carbonated skin, clean, confident number. Wrong hammer type, clean, confident number. One lazy swing over a piece of rebar, clean, confident, completely meaningless number. The dial never flinches, so being worthy of this tool isn't about swinging it hard or fast. Anybody can do that. It's about knowing, in the moment, when the hammer is lying to you. Here's the Hall of Shame. 8 ways to swing it wrong. Calling the rebound number, strength, the original sin. Grabbing the wrong hammer type. Skipping the sight correlation. Taking 1 reading instead of 10. Striking over rebar or too close to an edge. Testing an old carbonated surface and trusting the high number. Mixing orientations without logging them. And never calibrating. Look at that list and notice, every single one of these still lights up a clean, believable number on the hammer. There's no error message. That's exactly why this tool humbles people who think they've got it figured out. Which brings us to worthiness. It was never about swinging the hammer. Anybody can press it to a wall and read a dial. The pro is the one who can say out loud, "This is a screening number, not a verdict. Here's my correlation. Here's the orientation I used." And if you want a real strength answer, we pull cores. That kind of honesty, knowing exactly what your number can and can't say, is what actually makes you worthy of the tool. The hammer respects that. So do inspectors. Let's lock it in. Verify on the specified anvil to your hammer's stated range. Prep the surface, clean and smooth, moisture noted, at least 4 inches thick or rigidly backed. Avoid rebar, stay a couple inches off the edges, and account for carbonation. Take 10 valid readings, an inch apart, perpendicular. Discard any reading more than 6 units off the average, and toss the whole set if more than 2 are off. Log your orientation, and never, ever call the result strength. If you want it in one breath, prove it, prep it, spread it, average it, and never call it strength. It's a screening tool, not a verdict. Carry that, and the hammer becomes something you can actually stand behind. Here's the one to screenshot. The whole rebound test on a single card. Before you swing, the right hammer and impact energy, verified and working, and know your purpose. Uniformity screening or a strength estimate, because you only need a correlation if you're reporting strength. Clean, smooth surface, moisture noted, member suitable and supported. Striking, stay off rebar and defects. Keep every hit 2 inches from edges and an inch apart. 10 valid readings, perpendicular and firm, and check each mark. Re-hit if it crushed a void. Read and report. Record each to the nearest whole number. Discard anything more than 6 units off. Toss the set if more than 2 are off. Log your hammer, orientation and moisture, and report a rebound number, not a PSI. Snap a picture of this one. So here's the shift. Put the hammer down as a magic strength wand and pick it up as a screening tool, because that's what it is, and that's where it's brilliant. Become the tech who knows exactly what it can say, and, just as important, what it can't. That's the difference between swinging a hammer and reading a structure. And the folks who read the structure, right, they're the ones who get asked back. Now, the rebound hammer is one tool, and we just went deep on it. But here's the reality of doing it right at every location. It is a lot of fiddly math. 10 readings. Find the average. Throw out anything more than 6 units off. Retest if too many are outliers. Apply the orientation correction. Track your anvil verification. and then write it all up into a report an inspector will actually accept. That is exactly the busy work. The My Concrete Life Rebound Hammer Workbook is built to take off your plate. It's called the Rebound Hammer Workbook, and it is an Excel tool that runs the exact method we just walked through. You type in your readings, up to 12 per location, and it does the rest. It discards the outliers, averages what is left, applies the orientation correction for up, horizontal, or down, and drops it all onto a clean, professional ASTM C805 report page. It even tracks your anvil verification and your calibration due dates. Readings in, a report you can hand over. Out. Here's what's inside, and none of it is fluff. You enter up to 12 readings per location on a guided form. It automatically tosses any reading more than 6 units off the average, and means the rest, the discard rule built right in. It corrects for orientation, up, horizontal, or down, and logs which one you used. It will give you an estimated compressive strength from the modified values, and remember today's lesson. That is an estimate, so for acceptance you still correlate it to cores. It tracks your calibration so the hammer stays honest, and it prints a professional report page for the field or the lab. It is the whole back half of this lesson, automated. So let's land it. The Rebound hammer is a hammer, not a crystal ball, so swing it like you know the difference. Prove it, prep it, spread your 10 readings, average them, and never hand someone a PSI that the tool never actually measured. The free Rebound hammer checklist you just saw is on me, linked below, and if you want the readings, the corrections, and the report done for you, the Rebound Hammer Workbook is right there too. Be worthy of the hammer. I'm My Concrete Life. I'll see you on the next pour.